Hello, everybody. We're here with our teachers from CS4-Alabama for our professional development in October 2015. And we have joining with us from Indianapolis live, Michele Roberts, who's with IUPUI and the Department of Computer Science. So Michelle's been one of our experts in data, and she has some activities and some discussions about the content of data that we'd like to share with you for CS principals. So I'm going to go ahead and kick it off, and I'll control some of the slides. And Michele, it's all off to you.
Okay. So good morning, everyone. I wanted to let you know that I'm a Southern girl. If I get really nervous, my accent will come out, and hopefully you will have some mercy on me. I live about an hour north of Indianapolis. I'm a transplanted Southern girl, and today I see you in your sweatshirts, and I wish I had one of those and some coffee and donuts. We had our first hard freeze last night, so I hope you're enjoying some autumn weather there. I have to, going to start with an apology or maybe a warning. You might see hands moving in. I have commandeered my spousal unit's office, and he is here grading papers. And if my PC drops off the desk, those will be his hands coming in to grab it. And it gets even worse. My college kids surprised me by coming home last night. So hopefully there won't be any young kids bursting in their skivvies asking about breakfast. I wanted to talk a little bit about how wonderful you all are. I always try and say yes to the things Dr. Gray asked me to do, because Alabama is lighting the national map on fire, and that's largely you all. So all of us involved in K-12 outreach are just really, really grateful for everything you've done, including getting up at a ridiculous hour on a weekend. Let's jump in, if you're ready, to the data unit. And I want to walk through a few slides that Jeff will be able to hopefully present there. And we'll put these up on the resource section of the MOOC if you find anything hopefully helpful there to you. So what is the lowdown on data? I want to give you just a couple musings at the beginning. I think that there is an amazing amount of content available, ready to use, turnkey, when you teach the data unit in the principles class. I think what we're missing is a little bit of an organizing principle and some specific identification of core competencies that we want the students to exit with. And I am hoping that we can discuss those and clarify those today in the little bit of time I have with you. So Jeff is going to advance the slides, and here's what I want to cover. I want to make sure we make an explicit connection between the data big idea and all the other big ideas in the principles curriculum framework. And I want to make sure we have some specific goals for the students and identify some activities that I at least have found helpful in trying to give our students these competencies. So advancing to what I call my little wheelie slide, here is hopefully what you're seeing is a picture of all the principles ideas. And let me just remind you that these are uncoupled only artificially so that we can study them, but in reality, not only in the real world, but in the discipline, all these ideas are threaded together. And I think the idea most closely coupled to the data thread is abstraction. So, but let's walk quickly all around the wheel so that your students don't have this sense that data is just out there somewhere without being firmly connected to the other ideas. So, if you think about it for a minute, whenever we construct a piece of data, it's an abstraction. It's an abstraction about some idea or process or thing in the real world that we are trying to study or explain. And so if you walk this idea that data is an abstraction all around that little wheel, you'll see that we use algorithms to manipulate the data. And one way to think about programming, for example, is it is programmatically algorithmic abstractions that we just manipulate. If you think about how we transmit data, that gets you very quickly to the big idea of the internet. And I think you all did one of the most famous Unplugged activities yesterday about routers and packet movement. Again, abstract pieces of data. And the idea of data itself is always in the news. You hear a lot about data breaches and big data, all the databases you are in. You read about those and blown to bits. So I think you can see that if we move around that little wheelie, data is very visible in all of those constructs. So let's kind of think about the life cycle of a data unit. You have an idea, a construct, an object, etc., and you abstract it into some sort of representation, and then you're going to explore it in a number of ways. So these are going to turn out to be the objectives, I think the learning objectives that we're going to establish for the data unit. So different ways we can look at data. You can perform summary measures on just single abstractions. We can look at multiple abstractions. We can do schemas. And then we can go even bigger and look at models and simulations. So if you were to kind of step back and say what disciplines feed the data unit in the CS Principles class, what specific areas of what CS people do, you're going to see this presence in data science, data analytics, database work, data mining, etc. So think of this as an iterative movement through a life cycle. Your students hopefully will have a little Scooby-Doo movement where they say, what's going on here? Or they'll make an observation, or they'll have an idea. And they construct, we all construct data. So it's very creative, and we measure how close we get to the real world with a construct called fidelity. So some data ideas have stronger fidelity to the real world than others.
Michelle, can I interrupt for just a minute? Can you make sure you cue me on the slide?
I can. That really nice gentleman in the front row was making circular motions because I think he figured out that I was out of sync. So if you keep, if my friend keeps doing that and keeping me honest and all together, that will be helpful. And I have moved to a slide that's 5 into the presentation.
What's the title at the top? I'm sorry.
The title is, How Does a Computational Thinker Do Data Analysis?
Thank you.
So thanks again to my friend there in the front row. So again, I want your students to have this idea that this isn't some cold, sterile, abstract thing. It is both at the heart of teaching and at the heart of the scientific method, and as we'll see here in a moment, at the heart of most of the arts and sports. So I'm going to go ahead now, Jeff, and look at slide 6. What I did when I approached how to handle the data unit was to kind of make a roadmap and say, you know, as teachers, we need some sort of organizational theme to a unit. That makes this more comfortable, and I think it creates better pedagogy because then our students can sort of see that thread as well. And it seems to me that the way we should organize the data unit is along the lines of abstraction. So if Jeff will click to the next slide, you will see my thought at levels of abstraction. So when I teach my unit, I start with a single data abstraction. And what kind of things, what kind of competencies would you want your students to have? Well, I think at a bare minimum, they should be able to do measures of central tendency and measures of dispersion. So let's remind ourselves that the principal's class is positioned not just within a math department. If you have students with a math background, obviously you can take this much, much further. But I purposed my curriculum for students that have tried to run as far away from math as they could possibly get, as fast as they could run. So this is just a minimum set of things I think a CS principal student should be able to do. And when I introduce this unit, I'm going to show you some of the things that I do when I'm in this thread of single data abstractions. Because I go out of my way to try and bring non-classic STEM students in, I want to make sure that they have real tangible things that they can relate to when we start talking about these constructs. So I do this activity called Who's in the Box. The concept that I give the kids is why do you care? Why are we doing this? So imagine that you have some sample population and you can't take the time, you don't have the tools to interact with every single person in your little world. So of the people I put in your box, could you give me some summary information about them that would allow me to draw a pretty accurate picture of who's in the box? And what I put in the box are clothespin people. So for example, let me just show you something that both in STEM outreach and in my class that my students have really enjoyed doing. They decorate little clothespin people for me. So the point here is to have some really fat people. And then I do a lot with zombies. And so I have some really skinny, hopefully little scary zombie people. And I put an arrangement of these people in different boxes, and the students get a box that they can open that has a little index card that will say something like, there are 10 people in your box with an average weight of 200 pounds. And then the students have to fill out a spreadsheet about who the people are, describing the people. And the first time the students do this, they will make every person in the box the same. And when they open the box, though, they'll realize that they have 9 really skinny zombie people and 1 really, really fat sumo warrior that's throwing the stats off. And this will then give me a setup of saying, hey, it's not good enough to just take an average. That's why we're going to spend some time. I use Excel. Hopefully you have access to Excel. I use Excel to manipulate a lot of data sets. So I will give the students a data set of people and then have them calculate, for example, the measures of central tendency, just the mean, the median, and the mode. And then for dispersion, we do a range. On this little chart, you will see that a couple of the ideas have a C in parentheses next to them. And from my experience in the classroom, my students don't typically have the math skills to really understand how standard deviation is calculated. So I just talk about the concept. So if there's a C there, I would say on an exiting competency, they just need, to know the understanding of the value of a standard deviation. They don't have to be able to calculate it. But I do think they can easily calculate in Excel. After all, it's a button push. They can calculate the mean and the median and the mode, and I construct specific examples with a data set to show them that relying on just one of those measures will not give them an accurate view of their population. So I hope you'll have some fun with something like the little clothespins. Every semester I provide all the materials, so I worry about equity, but the students have to use my materials, and if we have 5 or 10 minutes of downtime here or there, they can always pull out one of these construction kits and make yet another clothespin doll. So what I would like to do at this point is, instead of just having an activity at every level of abstraction, I combined some of these because, after all, it's a Saturday morning, and there are more exploded, detailed activities that I'll put on the MOOC resource site in case you're looking for more things that you might want to explore with your students. But are there any questions around just single data abstractions? Would this fly with your students? Are your students already way advanced than this? Give me a little feedback.
Michelle, I think it's the case we have so many in the room. If we had 2 or 3 people, we may get questions, but I think this is what a lot of people.
Okay, no worries. I just need your promise that you will act like my friend there in the front row with the little hurry it up or you're way lost, or so give me, if you have any questions, feel free to interrupt at any time. So what I'm, yeah.
We're on this table that has competency at the top.
Dr. Gray.
Yeah.
Scotty's had to explain to me the clothespin.
Okay.
If we wanted to do that activity,
Right.
I don't exactly get it. I got it when Scotty told it to me.
Okay.
Maybe if
So Michelle, what we're doing is showing the slides. We're not seeing you. So if you were actually showing something,
I was.
We're not seeing any of that. We have all the slides up.
Okay, can you bounce back over to me and I'll show you the little people?
Yeah, probably we should have had you drive the slide. Well, they're seeing my kids now, so they have to this out. Okay, there we are.
Now can you see me? Okay, so what I have my students do, and I put these in a shoebox, and under pain of death, they can't open the shoebox. On the top of the shoebox that I filled with a selected set of my little people, I have little fairy tale people. You can go on Pinterest, and there's a million sites where people have created little clothespin populations. I wanted to show you, I have Albert Einstein. Can you see him? So there's Einstein. I made a point of making sure that anyone in my class would find some representation of themselves. And then, as you're going to see here in a minute, I do a lot of work with zombies just to kind of keep the kids from falling asleep. So when I load up my box, the cool thing about zombies is everyone seems to know that they get all skinny. And so when I load up a cardboard box and put a card on the top that describes the people, I will say you have 10 people in your box and they have an average weight of 200 pounds. And the first time students do this, and then I'll say, go into Excel and create a row for each person describing what they're like, and give them whatever attributes you want. And the students will give them, they'll give them storylines, they'll give them funny names. So I let the students be creative. But the first time they do this, they will always, I mean, always, they will divide the weight by the number of people. So they will think that everyone weighs 200 pounds. And then when they open the box, I've rigged it so they have one fat sumo warrior with a little tag on his back that says he weighs 800 pounds. And then they have 9 really skinny zombie people. And so then maybe I let a week go by, and the next time we do the exercise, the students will know to rotate the weight around the average. And so instead of saying everybody weighs 100 pounds or whatever the number is, they know to say, oh, a few weigh 105, a few weigh 85, but I promise you they will all gravitate around that average number. And then later on, I let a few more weeks go by, and you can introduce the idea of skew in your data set. So the point is for them to physically experience with manipulatives why it isn't just okay to take an average, why we look at two measures of central tendency, how close your data is around a central point, and then measures of dispersion. So if you're a math teacher or you're a stats teacher, you will probably weep inside with how further you could take these ideas. And I encourage you to do that. But my principal students come to the principal's class with very little expertise or understanding of stats and with very little experience with abstraction. So I start my data unit the first week of class, and I just do little pieces of it. I do the same thing with the programming unit. And here's why. You all know this as teachers firsthand, because since there's no way yet for teachers to pre-cert in computer science, how have you had to get your training? We bring you in and it's like swallowing from a fire hose, right? If you're a math teacher, you've been studying math for 12 years and then you studied it more in college. And on top of that, you took a methods class. But here in one workshop, we got a fire hose all the computer science in and the methods. And I think you can appreciate that there's a run rate to absorbing ideas. It really isn't that these ideas are hard. You've dealt with harder things. It's that these are the kind of ideas that you got to kind of let noodle around in the background. So the same thing I find is true with my students. I can't just do a programming unit in 2 or 3 weeks. I run that thread all semester long, and I do the same thing for data. So I'm just suggesting that you start data early and you thread it with short exercises throughout your semester or school year. Did that answer your question about what was I talking about with the little peoples?
Yeah.
We're good. Are we good? Okay.
Can I go back to the slide? Can you just cue me up on whether we're at slides or?
Yes. So now I'm going to bounce back to the slides. Okay. And I want to, I'm back on slide 7.
Okay.
And what I wanted to do here was to, I condensed the activities because we won't have a lot of time together. When I teach this in my class, I have activities that are only simple summing measures around central tendency and dispersion. But what I'm going to do with you guys are going to get a twofer, one of those two things in one. So I'm bouncing up to the next category, which is instead of just looking at a single abstraction, I want to up the ante by looking at multiple abstractions. And the activities I use here, again, I'm hugging Excel. I hope you all have access to Excel. I don't think you'll find a stronger tool for the data unit. So what I do here is this is where I work with my students on pivot tables. They should be able to take a data set and in a heartbeat, create pivot tables. Just to talk tool for a second, although I don't want to be dependent on the tool, if you have Office 2013, teaching pivot tables will be one data button push. It's so much easier than we had to work with in the past. So hopefully you'll have access to the latest version. But I walk through students through pivot tables, which is just summarizing data by category. I spend a lot of time on charts. And what I find at the college level even is students don't know how to read a chart. So Jeff, if you would right here, jump over to the resource Excel sheet, because what I wanted to show the teachers is what I've given them by unit.
So just as a pause, all of this is now out on the CS-for-Alabama drive, including the presentation. So if you can't see the presentation, it should be out there. You may have to do a refresh of the drive.
Can you project the Google Drive for them so that they all can actually?
Sure. Let me just show you.
Really helping. Following the presentation as he was talking on my computer, I was able to connect much better.
So all of the presentations are under the October PD resources under year 3. And in that presentation, as you can see, there's the data lowdown, which is what Michelle's printing right now, or talking about right now. And then inside of that, you can see all of her presentation. And then over there in October PD, there's also an activities folder and one called another folder called data. And inside of data, you can see all of the resources that Michelle will be sharing with us. So there is the data resources Excel file that I'll be displaying now. And then there's several activities that she's given to us that you could try in your class. They could probably take an entire day's worth of observation with your students. So all these are now out on the CS-for-Alabama Google Drive for you to access. So if you want to follow along with her in the slides, that would also be great. But I'm going to go ahead and show the Excel spreadsheet now that has all the resources. Okay. So Michelle, that's on our screen. Now we can't see you, but we see the spreadsheet.
Well, you're trading up to that Excel chart. So I'm going to come back in just a minute and talk about the computational thinking resources. But I want to let you know how I've organized this. If you look down on row 12, that matches. So this will match up to the chart we were looking at a second ago that hopefully gives you an organizing principle to the entire unit. And I listed some of the activities that I do. So you'll see listed there who's in the box clothespins. The next thing that I listed is Excel. There's a million YouTube explorations of how to work Excel. And in particular, I would make sure that you can show your students, sadly, Excel gets relegated to just being a list. We keep track of whose turn it is to bring the orange slices to soccer practice. And Excel is so much more and will be a backbone in your data unit. So buried in Excel are things like descriptive statistics, charts of every flavor, pivot tables, scatter plots, scenario planning, and what-if analysis. So your students can actually build really primitive models. And I know we don't have very much time, and it's way early in the morning, but I've just listed that as you gear up for the data unit, I would make sure that if you don't know how to do those things in Excel, feel free to call or text me. I would love to show you if you can't locate a YouTube tutorial, but you should be able to do those things in Excel. My students just don't know how to read a graph. And if you think about reading a graph or creating a graph, that is abstraction in a heartbeat. So the best little training tutorial I have ever come across is this how to read a graph tutorial that's done by the Concord folks. And it's an app that you can run. There's the link to it there. You can run that on either a Mac or an Android device. And it has some real world scenarios. So it'll say, here's what's happening in the kitchen, or here's what happened in your car. And then it'll show you a series of graphs to help you develop the ability to translate between us girls abstract that storyline to data presentation in a graph. So that's another go-to thing that I do if I have maybe 10 minutes here or there. The other few things that I wanted to call out, there's a really wonderful article that the CS Principals community distributed at one of our conferences, and it's also up on the MOOC called Charted Territories. And it's a nice way of having your students understand what data is best presented in what form of a graph. Here in a few minutes, I hope we'll be able to come back and talk about infographics, because what students need to understand is knowing an answer, having an idea, but not being able to present it in a cogent and compelling way is a real tragedy. And so I hope you'll be able to follow some of the activities in the infographics section that will give them some experience with one particular story that I called out is infographics around the London cholera epidemic. It's a great story. So I gave you a couple of links. This would be wonderful for group activity. So in these links, people talk about the cholera epidemic as it was raging through London, and folks who, in order to convince people that they should dismantle a water pump, had to produce some of the first charts and graphs. And to this day, the health organization awards annually and internationally an award in the shape of a water pump handle. So that's a great story for your students in small groups to read through, and then look at some of the infographics that have been produced around that. I also gave you some links there to typical magazines like Wired. If you don't subscribe to Wired, you should. It's a great source of content for your students. And Wired once a year will publish the top infographics of the year. By the way, if you are on Facebook, you have probably been passed already 50,000 times that Coke infographic of what happens to your body within the first 5 minutes of drinking. And I'm a great Coke fan, so if you've seen that in an infographic, it made it to the top of the list already. So there's some resources for you to put together an extension of your unit on graphs to include infographics. What I would like to do is help you stop listening to me just for a second, and let's go look at the first activity that I put together for you. So again, I combined single data constructs along with multiple data constructs, even though I've called those out on the resource file. So Dr. Jeff is going to go get the activity for single and double resources, data constructs. So this should look like, let's see, single and multiple variable data sets, the Word document.
Yep. And it's also out on the Google Drive if you want to pull it up on your own laptop.
Okay, so let's just look at the activity, and what this activity, all the activities are going to be a little set of instructions, and then typically a data file that will come with them. So what you should be seeing is, let me look at my notes here. So this is launching really slowly on my home computer. Hopefully it's up with you already. So what this activity is going to do is I supply a worksheet with a data set. And of course, the data set is about zombies. We'll be using that in several activities here. And hopefully Jeff can also bring up the Excel file around the zombie data and pivots and scatter plot. So the background story is this. Your class is involved in a zombie contagion, and there is a zombie net, and it has trapped some potential zombies. And you're in contact with the Center of Disease Control, and they have said right now we're focusing on a single data construct, in particular weight. And so we some measures of central tendency and some measures of dispersion. So that's point number one. So they'll just use Excel to calculate those numbers. The second question says everyone captured in the net are denying that they've been infected. And blood analysis is going to take too long. Look at your data set and see if it's worth isolating someone. So this would be the concept of, do you have any outliers? So I'm hoping there will be some discussion and group presentations when you do techniques like, pair share out to the class. And then the third thing is going to allow us to look at pivot tables. So as we're trying to explore, how do you really identify a zombie? Maybe if we classify the data into categories, we could see some patterns. So that's going to be a request to create a pivot table. And then finally, we want to show a scatter plot to see if it really does look as though if you know a person's weight, you can tell if how many days they've been infected. So that would be the activity. And then let's go look at the data set that I provided. So Jeff, what I'm looking at now is an Excel chart that is entitled Zombie Data plus Pivots plus Scatter.
Yep, we're on the raw data.
Okay, so when this comes up, give me a second to catch up with you. On the
as a handout too, so everybody's got this in their hands. I printed this out.
Oh, fantastic. So my students don't realize that there are tabs on the bottom of an Excel worksheet, so you'll need to make sure that you remind your students of that. So here is just a data set around information on zombies. I have a conversation with my students about the creative nature of database work, and so gender should be has become more interesting of late as folks who capture data for a living have changed some of those definitions. So that might be a conversation. Their status, the C means you have confirmed blood work. So you're definitely a zombie. And then L means your blood work is still in the lab. I don't know days infected for all the folks. I can only know days infected from the lab work. So you'll see some blanks in that column. I captured weight loss just from those folks that are confirmed zombies. And then you'll notice hopefully some Alabama cities that I threw into the location column. So that's our raw data. And then let's click across. The first thing here would be a pivot table construction, just showing cities and how many zombies have been trapped there. I'm guessing that you can't see my mouse movement. Does anyone, let's look at the data set, and then if anybody needs to see just how easy creating a pivot table is, we can switch over to my machine, or we can make Dr. Jeff work on the fly. So here's a...
Michelle, do you know how, we probably should have maybe asked this at the start. I don't know if you've ever tried to project your screen in a Hangout before.
Nope, I haven't.
Yeah, so it's really easy to do. If you want to keep me, I can go out and do these too, but if you wanted to try it, it's actually, if you look at if you can pull up on the left, move your mouse over to the left of the screen.
Okay.
Some buttons.
We're trying.
You see screen share at the top left?
Yes,
So
I see. Yeah.
that, then we can see everything you are projecting off of your own screen, and it takes away from the video and goes to your computer.
Okay, so I think I'm here. Did that work?
No, not yet.
Okay, I bet it would be helpful if I pressed start screen share.
There we go. Perfect.
Oh, perfect?
Yep.
Okay, so good. Does anyone need a reminder of how to do pivot tables, or are we good? Just shout out what you would like to see.
Can you enlarge the screen, like the Excel, zoom in or something a little bit?
We can try. Let's see. That help?
Yeah, perfect.
Okay, so let me just step across the bottom, and then if you have any questions around how to do any of these charts or graphs, just go ahead and stop me. So here I'm going to go look at a pivot table by gender. And, you know, just remember, this is the playful teasing out of what the data means. And in my pacing guide, if you would like a copy of my pacing guide, I will have already talked about the periodic chart and the story about how Mendeleev did the equivalent of index cards as he sorted and resorted the chemical elements before deciding on an organizing principle. And so it was this, in effect, he was supposedly, and if it isn't true, it ought to be, he was creating, he was using pivot tables to sort and resort the data. So we do this just to help tease a pattern out of an otherwise big mash of data. So here's a look at what cities are falling fastest to the zombie contagion. I hope none of you are from Birmingham, because it's not looking good there. Let's go over to top locations for gender. So here, this is broken out, just, you know, different ways of looking at the data. So maybe in our case, there's some natural anecdote that one gender might have over another, etc. So these are the kind of things that you're looking for. So let's keep going quickly. Here's a chart of the location. So once you've constructed the data set, it's just a second button push to get the charts. And when I have my students do this, you'll notice that I put a question. So I give them template sheets that they fill out, and the question's on there. What question are you trying to answer? So I think anytime you can make explicit, you know, what they're going after in the data, that at least helps my students a little bit. And then lastly, here comes the scatter plot. So you can see that, yes, there is a very direct relationship. All those little points are hugging the line. So I don't go into the math of correlation coefficients or linear regression, but again, they should be able to get a visual that the closer their data set is hugging that line, yep, they found some kind of pattern. So I'm getting a little bit nervous about the time we have left. I do want you to do a hands-on activity with me. So I'm going to move to the next level of abstraction, if that's okay, and you can come back and ask any questions that you want. So if we go back to the PowerPoint slides, we had made it to we started with single data abstractions and multiple data abstractions, and then we combined that into one big activity. And I'm going to skip over schemas and come back to that. But Ms. Stipa asked me to make sure that I had some time to talk to you about models and simulations. So what's important to make sure your students understand in models and simulations is that there are two parts to the data now that are absolutely critical. Not only do we have multiple data elements in play, but there are rules describing how those data elements work together. And then if we run those data elements and the rules with how they interact, we would get a simulation. So let's flesh out some ideas around modeling. And I'm going to have you bring up the activity sheet. Let's quickly do the activity sheet for schemas, even though we won't have time to do all the schemas. I'm going to give you a break for having to listen to me by bringing up the mining for meaning spreadsheet and the, mining for meaning Word document and the criminals spreadsheet. And I think you have those in a handout. So if you have a second, what you should be seeing here, and you should be able to look at it there on your handout, in this mining for meaning, this is my pre-game for going into database work. And you'll see some great tutorials are emerging. Code Academy has one, W3 Schools has one. You'll be able to go from not knowing anything about databases to doing some significant database work with your students. But let's just focus here on the pregame, because I want to make sure your students understand the connection between database work, programming. And hopefully you'll see there on your Word document that all that's going on in a database application is a particular kind of programming that happens so often for people interested in data that folks have abstracted out of a bigger programming language some instructions that come up over and over and over in data mining. But behind those, that language, which is SQL, really a specification, don't tell anybody, but behind the SQL, you should be able to see the kind of programming constructs that your students have been using in Snap or Python or whatever language you're using. So behind all this, the database magic fairies are going to issue a repeat. So this is going to be one big loop until you've moved through your entire data set. And what you're going to do within the loop is, for every record, check to see if it meets a condition. The same kind of conditionals that you taught your students in programming. So they should see an immediate connection there between what are we doing in database work and how does that relate to a programming construct. So let's cut right to the chase of the pregame exercise. If you would bring up the criminals database, the criminals spreadsheet, sorry.
You have this also.
I run multiple versions of this throughout the academic year, and they become progressively harder. So at the beginning, I lace a spreadsheet with some rules where you are applying a conditional to a data set. So this is Boolean logic. It's working on your conditionals. And at the beginning, there really is just one right answer. But as I've built up the capability of my students to work in teams and collaborate, the final exercise that I do like this, spy related or criminal related, I've laced the clues so that there are two possible candidates, and groups are going to have to make an elevator pitch at the end, arguing why one choice is better than the other. But working with whoever's sitting next to you there, so this is an opportunity to maybe grab that last bite of donut they've left on their napkin. Working with some partner there, let's process some of these clues. So if you look down at the bottom of this sheet, you will see some clues. So it's down in the bottom right, and I didn't want to print this in color, but if you can do this unplugged, but it's more fun if you can do it in color. to make sure students aren't just randomly crossing names off the list, I have students, when they eliminate a row, they have to highlight the background color to match the color of the clue. So that way, if we get a wrong answer, we can go back and figure out where our Boolean logic went awry. So let's just quickly shout out as we try to identify who this master criminal is here. The first clue says whoever the nefarious person is, their name does not start with the letter R. So I won't worry about getting the highlight color right. Let's just, you can take a pencil, and who are you going to knock off at this point?
Becca.
Yeah, so you should find, I think, 3 people whose name starts with R. We can get rid of Rebecca, we can get rid of Rachel, and we can get rid of Ryan. So did everybody get rid of those 3 people?
So yeah, I'm highlighting them as 0.
You can either do it as an unplugged activity. If you do it online, I require my students to color code.
I got 3.
So you should get rid of 3 of them. You should find Rebecca, Rachel, and Ryan are now out of the potential data set. And the next clue is the criminal or spy is over 18 years of age. So this is an opportunity to talk about boundary conditions. Over 18 does not include 18. So you should scan down and knock off anyone. Tristan, for example, is 18. I put someone in there who's only 12. We already got rid of them, I think. Desja is out now, coming in at 18. So I think you knocked off another 2 or 3 people. Ferris is out. Tristan is out.
Right.
Desja is out.
I don't think that's possible.
Desja is down on row 26. And I thought I put somebody in there only 12 years old, but I'm not seeing them. Okay, so do we think we got rid of all the folks 18 or younger? So let's go get the next clue, which is they would only commit a crime when they're in some kind of costume apparel. And here, this is a great opportunity to talk about the creativity involved, again, in being a data analyst, because you'll have some interpretation here. So if we scroll up to the top, here's the folks that I would argue don't count for costumes. I don't think cement shoes is a costume. An accent isn't a costume. So my first one would be row 8, Alexis. The minion costume is definitely out. So even if we don't get the color code, that's all right. So minions are out. Number 9, the Halloween mask is out. I would argue makeup is not out, so Indepret is still in. Number 18, magician's gloves should be out. The sweet grandma costume is out, so just knock them out any way. Pick one color and just stick in it.
How about?
Time out.
Yep.
Are we supposed to be eliminating costumes or not? On here it says we only commit a crime in some kind of costume apparel. It's like you're eliminating the opposite.
That's right. So you're keeping in the people who are in a costume, and you're getting rid of everybody who's not. You are absolutely correct. It's a not.
So are you highlighting the correct things? I thought we were highlighting those that were not.
You are highlighting the people who you can knock out. So you're highlighting anybody who's not in a costume.
So are you highlighting the right people? Because you're highlighting minion costume.
No, I was not. So I'm fixing that quickly. Thank you for being so alert. And tell Dr. Jeff to cut off your coffee supply. So let's go back up to the top. Sorry. And we'll knock people off. So Ferris is not in any kind of costume, right? So Ferris is out. Row 2 is out because he's not in costume at all. Rebecca is out because a cane is not a costume. Brooke is out. Andrew's out. Quentin's out. Morgan's out. So I think we've killed off everybody up until number 8. Alexis is our first person that's still in. Are we good? So Morgan's out. So number 10, Melina is out. The blowtorch is out. So 11, 12, and 13 are all out. I'm going to kill off Indepreet because she only is wearing makeup. That's not a costume. Rachel was already killed off. We're about to lose Monica. So I'm going to keep in Magician's Gloves. I'm going to get rid of Chelsea. I'm going to keep in Vicky. I'm going to get rid of 21. Alicia's out. Jeff is still in the Star Wars costume. And I'm going to lose, I think, everybody else. So Luke, Michelle, Kayla, Kevin, Justin, Cole, and Tyler are all knocked off. And then everybody else is off as well. So Tyler, Jessica, Michael, Lynn, and Anthony are all off. And I think we're just down to a few people that we're about to kill off now. So I need to find people who hate orange and brown. So if anybody likes orange or brown, they're dead. So goodbye to Lauren. And now I'm going to kill off anybody who's in a lower socioeconomic status because my criminal is middle class or higher. So now I'm going to lose Alexis and Angela. And finally, I'm going to lose Vicky, which unmasks one certain Jeff G, wonder who that could be, as a dark web lord. Okay? So what's important is to traffic back through this. And if you look on the assignment sheet, you then need to repeat this exercise, but write out the conditional for each clue. So, for example, if I had given you a clue that said hates blue, you would write that as a not favorite color gets blue, right? So you want to reinforce your students' ability to make explicit their Boolean thinking. Everybody okay with this?
Yes.
Okay, so I have a bajillion data sets made up like this. If anybody wants them, just give me a shout. Glad to share them with you. Let's bounce back over to now.
We're getting a request. We don't want a bajillion, but just a jillion would be good.
Okay. Just let me know and I will send you anything I have. You're welcome to it.
We're letting you know.
Yep, send it, please.
Okay, no worries. So let's go look at models and simulations. So let's look at this activity sheet, and then I'm going to send you to a couple of different links. What I find, and I found this for 30 years, we don't lose students to the semicolons in programming. We lose them to the abstraction. It is something with which you need practice. And this is certainly true for models. So I start off really simple. If I'm a former student athlete, so I always try to bring athletes into my classes. I have students working in groups or partners go get something, some sort of thing for which there are models. So football plays, if those are worked out with X's and O's. Basketball plays, map out using X's and O's. Carolina, everyone runs the Carolina play, right? If you have music students, have them get a song that's written out in a musical score. That's an abstraction. Those notes are models. So if you have STEM students, the water cycle is famous, or the Krebs cycle, or just a simple molecule. And so what they need to do is to answer those 6 questions. Who are the actors in your model? And this could be something as simple as, a hydrogen atom, or this is the nose in a football play. And give me 3 rules about how your actors interact with each other. Because until I've established the interaction rules, I don't have any stinking model in play. I just have data sets. So is there a notational script? And give me a weakness to your model. All of them, every model will have a weakness because it's an abstraction. Hopefully you left out only those things that don't matter, but that's a weakness, right? And then how would you test the fidelity of your model? So in the real world, folks will run a little scientific inquiry against their model to see if it's predictive. So I would have my students start with that first. And then if you bounce back over to the resource page, and I'm going to bounce here so you can see it from here. Look with me on the models and simulation. If you don't have that little game in your classroom called Mastermind, oh my gosh, you need to go get it. That's a straight up computer science game, one of the best tools for thinking modeling. And I gave you a link. If you don't have one in your room, can't pick one up at a garage sale, there's free online versions. So in that little game, you use little colored pegs to create a model of the world. And then you guess against your predictive model. And then you can take the little shield off and expose the pegs and count how many clues it took you to test that model. So that is an absolutely great go-to game in computer science. Because all of us are always fighting for time, the CS Principles course is so broad. In my pacing guide for the data unit, I look for what I call twofers, exercises that pay off in more than one of the big ideas. And by the way, when you are debugging your code, when your students are debugging, have them articulate a model of how they thought the code was going to work, because, hey, it's not working that way. So debugging is a great tool. A code trace, just a manual code trace, is so important tool for the students to master. So I give my students, and again, if you want these, I'll give them to you. I have little snippets of code, and I have students work through in an Excel sheet a code trace for a loop that includes a branch. And they have to say what value variables are taking on and what happens at the system level. Does a print statement happen, etc. So if you don't have a set of those, you need one. And that's modeling. You're modeling the idea of a control structure. I have them do sports plays, music, dancing. If you've never seen a notational script for a dance, it's tiny little feet that move around. So that's another way of building up your students' capabilities of seeing models in the real world. And then I have to just go all crazy over two things. One is Project Guts, and then the other is Net Logo. If you haven't had a chance to see Project Guts or what's coming out of code.org in collaboration with Project Guts, you have got to go to that link. There will be a video on that link of one of the founders of Project Guts, which stands for Growing Up Thinking Scientifically, who talks about computational thinking. And it's a little 16-minute video. Maybe your kids are better behaved than mine. My students would not sit still for a 16-minute video. So I just have them watch the first 2 minutes, 30 seconds to kind of give them a view of what kind of thinking we're trying to develop here. And then pouring every week or so, when you go to the code.org site, more content is becoming available. Until that flushes out, I am a huge fan of this Net Logo site. And if you can, let's go to this Net Logo site so you can see what kind of, I like load and go pedagogy. I've had laundry, I'm not having a good hair day, nobody gave me coffee and donuts, and I need something that's ready to play turnkey in my class starting in about 25 minutes. So that's my idea of good pedagogy, to drag and drop. So here I've gone to the Net Logo page. Hopefully you can see that. And I'm just going to choose the simulation with the people. So this simulation is a little revolution simulation. That might be a little too edgy. Hey, instead of clicking on that, maybe we've already clicked, maybe we should run a more benign one. We can run the little sheep and goats one. So that's in the upper left. So when this loads, this is what I like. Somebody has written the pedagogy for me, and here is a list of questions that articulate the model and the rules in play, and the questions your student should experiment. So, for example, they have given you who the actors are. In this case, there's wolves and sheep. That's in the simple model. If you want to go spring break gone wild, bring somebody else to the simulation, you can run it with sheep, wolves, and grass. And the students can, each of these little models will have a little screen where students can set attributes, speeds, or different things to play with in the model. And I put my students in groups, and I will just give them one of these simulations and require that they answer the questions. There are some two cool simulation models in here with some really probing questions. And so I make friends with the biology department and the chemistry department and have them come in and talk a little bit about predator and prey and things like that. So I turn this into a week-long exercise. So this is a great site to come to, not only for interactives, but the pedagogy is written right there, ready for you to drop it right into your classroom. So I'm going to go back now to the Excel chart, and let me just tell you another site that I found really helpful in the data unit, and that's Think Outside the Box Explorable. And the specific, you can grab all kinds of things from here. And if you are dripping in money, you can pony up $20 and get a list of every little activity they've ever done. But if you look on the Semmelweis and germ theory model, this is, I think, a very poignant story about the stewardship of a data scientist to not only understand something, but to be able to present his or her findings in a compelling and cogent way. So if you don't know the Semmelweis story, he came up with the germ theory and was trying to convince doctors early on with the advent of hospitals that perhaps they should wash their hands as they move from patient to patient. And sadly, nobody believed him because he was talking about tiny invisible creatures that jumped onto a doctor's hand, and he died insane. So there's a nice write-up there and some information about his model, and I use that as one of my social impact go-tos. I want to really quickly show you a computer model that I use in my classes. Have you ever taught a unit where you hope against hope somebody doesn't pay really close attention, like my friend there in the audience who said, well, I thought we were crossing out the folks that don't match? So, for example, when you teach the ASCII conversion table, you could perfectly, uniquely identify every character with some pad in just 7 characters. And whenever I teach that, I hope against hope the first day I talk about it that no really smart student goes, hey, wait a minute, if 2 to the 7th power covers every unique character, how come those characters have 8? And because now you're going to have to talk about parity, and it was only first week of class. In a similar way, eventually your students are going to go, hey, wait a minute, I thought you told me that at the executable operation of a computer, every little thing is happening in binary. But I just spent 6 weeks in Snap, and I don't see binary anywhere. So this is a little computer model. It's free. It's in the public domain, put out there years ago by this gentleman named Eck. And let me just show you, for example, in this model, this is a way of illustrating the fetch execute cycle. So in real life, your snap code gets disassembled, translated somehow, regardless of what programming language you're in. It will get translated or compiled somehow, some way to information that the computer actually understands, which is going to be binary. So information moves in and out of main memory to a central control unit in the computer. And let me just show you a simple program of how to add 2 numbers. So I don't have that really cute Snap GUI that allows me to pretend that things like adding 2 numbers is the level at which the computer operates. That is a level of abstraction that we spend our lives in. Underneath the curtain, just once, here's my code to add just 2 simple numbers, and you will see back in the day when I was your age and learning how to code, we had to manage our own memory, and you had to worry that you could set your data down in a safe place and not overwrite it with your program code. So here I've written a little program for you. I'll run it first in at the instruction level. And you'll see information brought in from memory and moving through the registers. So we'll just run this. Do you see the different cells lighting up as data is fetched through address registers, and some registers are named like the accumulator, etc. And then let me run the same, so you can see down on register 12 that you're actually doing an add and a load, and now this starts to look like a programming language. But then let me run the same thing in binary so that you see the computer comes and gets your cute little snap code and will fundamentally produce programming code that is nothing but a string of zeros and ones. And you can see the same data when we press run here, cycle through your code. So here's a run with the same, let's just add two simple numbers together. So that's a model. It's free. It comes with a set of instructions and commands that when you teach your students about the fetch execute cycle and how programming code is stored in a computer right along with the instructions. This is the best model I've ever come across in 30 years for showing how that really works. So a model about computing, if you're pressed for time, this is a great model because it's not only a twofer, it's also a three or fourther, as you can hopefully highlight some information with your students. The last that I want to hit, if we go to the activities for the models and simulation chart.
Michelle.
Yeah.
So can you give us just tell everybody the URL or where to go to Google and find this?
It's on the activity sheet listed by EC.
Right. So this, now I also have all the links you sent me. I put them out on Piazza.
Where?
It's the EC.
Computer operations of the third basic control structure. Right next to it's that one. There's under models and simulations.
And honestly, feel free to just send me a text message or an email if there's anything else. If you want more links or resources or an explanation of how I do it in the classroom, Dr. Jeff knows where to find me. And you can call or email me directly. And here's why. It's not that I'm a nice person. It's that I have learned over the years, when you give something to another teacher, they improve it and give it back to you. So hurry up and polish my curriculum, will you, by trying any of these activities and making them better. I want to visit one more model before we go on, and that's a link active from the model and simulation page. This is a zombie contagion model, and there is, we're going to go ahead and click on that and bring that up. By the way, there is a ridiculous amount of spoof, real science, but over a hopefully spoofy topic, where people have developed contagion models for zombies. And what you should be seeing now is an interactive map. And to kick off this last task, I have my students visit this site and just play with the model. So what this has you do is click somewhere. I have students click on any of the U.S. extremities, Florida Everglades, if you want to knock off New York or California, you just pick, and then I put something in the hinterland. And so there's a couple of different attributes that you can set. Notice that I just put a zombie in the Florida Everglades, and it is crunching its way through the state of Florida. And I have students watch this time up here at the top, and then they can play with these two attributes. So you can play, alpha is kill to bite ratio, so not everyone who gets bitten gets infected. And then the other is how long it takes the zombie to walk. And I have them use a spreadsheet and record different results of the contagion. And then that is my pregame to the last activity is to take them back to Snap and have them create a model with two agent types. So, you know, this can lead up to something that can turn into their performance task. So two agents might be a ball bouncing, or it might be something moving through a maze, or something picking up things, or it might be some sort of, you know, hopefully nonviolent shoot 'em up kind of game. what's important in their documentation is for them to identify the agents and make explicit the interaction rules. So for example, if they were creating in Snap a zombie game, they would have to articulate, if a zombie collides with a human sprite, then the human becomes infected. If the infected human can pick up some kind of sprite there in the Snap theater you created, it can be cured. So that's a way of combining multiple activities, programming, and modeling and simulation. They told me that I only had up until about 10:30. Gosh, I wish I could show you so many more things. We didn't even get to do any SQL or look at all the activities. But let me stop here and see if you have any questions. And then let me just promise that if you want the pacing guide or any of the other materials, just let me know and I will just infect you with a data contagion.
Michelle, can you turn your screen share off so we can just wrap up and see your face, happy face? Smiling at us?
I can try. Let's see. Did that work?
Not yet.
My spinning rainbow, did it work? My spinning rainbow stopped spinning, so hopefully that all worked. Wow, did you survive that data burst? You're still awake?
Well, I didn't know that your kids came into town, so that's really impressive that you stuck with us that long. So thanks for doing that.
Oh, no worries. Here's a good thing: when your college kids come back, they don't get up till noon anyway.
They're still in bed, huh?
They're still asleep, scattered on various couches and floors throughout my house.
Okay. All right. Well, thanks, Michelle. We really appreciate it, and lots of things we'll keep up to date with and connect back with you on. So will you all join me, please? And thank you, Michelle, for coming with us.
Oh, you're so welcome.
Excellent. I'm going to stop the broadcast just for a second.
Okay.